Hi, folks. My name is Lucas. I'm a software engineer from CodeMiner, and currently I'm allocated at Stack Commerce, which is a American e-commerce platform. And today we're going to talk about how we can enhance our web security with Captchas. We are going to try to balance user experience and security on this topic. This subject came into my mind because working on the e-commerce sector, usually I have to face challenges regarding this subject. So let's talk a little bit about it. Today we are going to talk about what are captchas, why should we use them for web security, the types of captchas and their effectiveness, best practice when implementing captchas, a few complements we can use alongside captchas to help enhance our security. We are going to give a small demonstration on how we can set up CAPTCHA on a Ruby-based application. And we're going to talk about a few technical considerations when implementing CAPTCHAs on our application. So what are CAPTCHAs? CAPTCHAs, they are tests that are designed to verify that users are human or they are a bot. It is widely used and includes methods that work in the background to detect the bot activity. So while these are very effective tools for identifying bots, they also have limitations. So the bots are becoming more sophisticated and often finding ways to bypass these tests. So why would you use captchas for web security? So some of the most common ways bot can target a website are the following ones. There are many other ones, but let's just focus on these ones for now. The first one is data scraping. So bots, they're programmed to pull information like prices, product details, articles, or user reviews, often to be reused or sold elsewhere. This is especially common with competitors or data aggregators who want to collect content from your site. We also have spam and phishing. So in this category, bots are often used to create fake accounts, post spammy comments, or inject links, usually to drive traffic to other websites or improve their search engine optimization. Some of these links can even be harmful and lead to scams. So that's a problem we try to avoid. We have also credential stuffing. That is a major threat. So bots will access your website and try to use stolen passwords and usernames combinations from other breaches on the web to see if they work on your site, especially if people reuse their password. And we all know that people tend to use their password on different websites. Another one is vulnerability scanning. That is another major threat. So bots frequently probe websites for outdated software or reconfigurations, looking for security gaps that they can exploit. So often with the intent to inject malware. So each of these threats highlights the importance of protections like CAPTCHA to keep bots out and your data safe. We have a bunch of types of CAPTCHAs, and we're going to talk about a few types of them and their effectiveness. We're going to talk about text-based, image-based, audio-based, Google reCAPTCHA, mathematical, logical, or puzzle, honeypot, and behavioral analysis. So these are the types that we're going to cover. Let's start with the text-based CAPTCHA, which is the most traditional one. It's simple and familiar, and that's its main advantage. So the users will be presented with a distorted text, usually with a combination of letters and numbers, and it will ask them to type what they see. So as I said, the main advantage is that it's simple and familiar, but the drawback is that many bots are developed OCR, which is optical character recognition, to bypass this type of CAPTCHA. So making it less secure than other modern CAPTCHAs that we are going to talk about. We also have the image-based CAPTCHA. So this is a more popular one nowadays. These CAPTCHAs show a series of images and ask the users to select the ones that match a certain criteria. as we can see on the right here, this example. So the advantage is that it is harder for bots to bypass because it requires visual understanding on simple text recognition, but it can be challenging for some users, particularly those with visual impairments. Talking about the visual impairments, we have the next type, which is audio-based captcha. So it is designed as an alternative for visually impaired users. These audio captchas, they will play a sound clip with spoken numbers letters that users have to enter to pass on this test. So the advantage, it is accessible for visually impaired users, but as a drawback, it can be difficult for hearing impaired users or in noisy environments. And also some bots have improved at recognizing our patterns and making it less secure. We also have, I think it's the most popular one, that is Google reCAPTCHA. On Google reCAPTCHA, we have 3 versions. The V1, which is already discontinued. It is very similar to the text-based one. We have the V2, as you can see here on the right. That is the checkbox, I'm not a robot. And we have the V3. So the reCAPTCHA has the following advantages. It provides different levels of user interaction. It is very reliable and widely used. So, but it can lead to false positives, and we are fully dependent on third-party service, which is Google. And this can lead to problems if we don't handle errors on the right way. So we also have mathematical or logical puzzle. These ones, they require a user to solve a puzzle or a math problem. The puzzles are like the following one on the right: dragging a slider to a complete image or ordering a set of items logically. The advantage is that it is hard to bots to solve because it is interaction-based, but the drawbacks are that it isn't universally accessible, and the logic might be guessable for some bots. Okay, now let's talk about honeypot captcha, which is very interesting. It is an invisible captcha. It adds a hidden field to a form, and since humans can see the field, they'll leave it empty. But bots will often fill it in, which will trigger an alert to let the system know that user is certainly a bot. So the advantage is that it is completely invisible for users, so it will maintain a smooth experience to real users. But it is less effective against advanced bots that recognize this pattern, these hidden fields. We kind of talked about behavior analysis capture, but it basically uses mouse movement, typing speed, or click patterns to determine if a user is human or not. It's often used by modern captchas like reCAPTCHA v3, as we already saw. It assesses behavior without interrupting the user. So similar to honeypot captcha, it is invisible to the user, and it has minimal interruption for legitimate users. But as a drawback, it may be prone to false positives, and some privacy-conscious users might not appreciate the behavior tracking because, yeah, it's Google. Now, after learning about the most known types of captcha, what we can see as best practice when we are going to implement in our applications. I highlighted a few topics that to us to discuss. So let's take a look at them. We need to ensure that we are choosing the right captcha for our application context. We need to match the captcha type with the security needs of our app. For example, a high security application might benefit from behavior captcha or reCAPTCHA v3, which assess bot likelihood without disrupting user experience. But for simpler applications, a basic checkbox captcha might be sufficient. We also need to balance security with usability. So options like reCAPTCHA v3 or honeypot are ideal for a smoother user experience as they work in the background. So high security applications may need multiple layers, but avoid excessive captcha challenges that could drive users away. So we need to keep an eye on this. We also could consider progressive challenges, like starting with a simple I'm not a robot checkbox, and then add more complex image or puzzle-based captchas if suspicious behavior is detected. So this layered approach minimizes the friction for genuine users, if you are worried about that. We can also combine CAPTCHA with additional security measures, such as rate limiting, IP blacklisting, or like device fingerprinting, especially for sensitive actions like login, form submissions, and payments. We're going to talk a little bit about this combining CAPTCHA with additional securities next, but we can also, we will need also to avoid the overuse of CAPTCHA and apply it only on selective pages on high-risk actions like account creation, login, or transactions, rather than every form or action to maintain a smoother experience. Lastly, we should monitor CAPTCHA performance and user feedback. We would need to track success rates, abandonment rates, and false positives, and we'll adjust the settings as needed to keep the CAPTCHA effective without compromising our users' usability. So let's talk about a few complements we can use alongside CAPTCHAs. So there are a few techniques that we're gonna cover on this one. The first one is IP and user agent blocking. So it serves as a first line of defense by blocking the high-risk IPs and suspicious users' agent headers that are known indicators of bot activity. So by blocking or flagging known bot sources, we are gonna rely a little less on captchas and block right away this bot attacks. We also have rate limiting, which is pretty popular. So this technique limits how many requests each user or IP can make within a set time frame. Let's say, for example, a user or IP can make only 10 requests per minute, and that's a rule that is set. It is effective for preventing brute force attacks and credential stuffing by setting request thresholds. So this will reduce the server load and helps deter bots while allowing legitimate users normal access. We also have device fingerprinting. This approach creates a unique identifier for each device by gathering details like browser type, screen resolution, plugins. So identifying recurring device patterns, it can detect bots trying to act like new users, even if they clear cookies or change IPs. And for more advanced bot detection, we can use paid services that are bot management solutions like Cloudflare or Akamai that offer enterprise-level security. So these services combine the IP reputation, behavior analysis, and machine learning to detect bot traffic and block it before it even reaches your site. So these are a few of the complementary tools that combined with Captchas can provide a robust defense against bots, enhance both security and user experience. So I've prepared a small demonstration here of how Captcha can be used to protect our applications. I'm gonna just share my screen again. 1 second. Okay. Just 1 second here. Okay. Here is a simple REST application that I built for for this demonstration. Let me right here. Okay, just run the application. Here. Okay, let's just refresh here. We have a simple application with a device installed. It is a Rails application. So set up a simple auth. And we're gonna use this tool here. It's called Zap to make a mini brute force on this page. I'm gonna create like 7 accounts, split of a second, because this application isn't protected by Captcha. So let's do this right now. I'm using this tool here, which is kind of a virtue for what I'm gonna do here, but let's do it. I'm just gonna put a valid password here. Okay, and I'm gonna select this. So basically what this tool will do, it will generate a new authenticity token each time of the request. It will pass this password, and it will pass this list of emails that I'm gonna add here. These 7 emails. So it's gonna try to create 7 accounts in a row by this automated method. So we are gonna just check how many users we have. The application, it's 0 users. And let's start the fuzzer. As you can see here, these 7 requests, they are being redirected. So they were successful. Let's try to see the user.count. Now we have 7 accounts created. Okay, so this might happen with your application in production. Of course, this is just a demonstration. It's not a production application. Let me just destroy these users so we can try it again with Captcha. So yeah, they were successful, even though they've been bot, not humans. And now we are gonna add a reCAPTCHA to our application, to our Rails application. If we search for it, we can find libraries for each language that you use, for the popular languages. I will use reCAPTCHA in this demonstration, so let me just switch my branch here, because I've prepared this. Add reCAPTCHA. So to add the reCAPTCHA, we can take a look here on what's being done. I just added the gem reCAPTCHA to our gem file and install it. And the gem CAPTCHA we need to configure. I configure by setting an initializer, passing my side key and secret key that we get from Google reCAPTCHA account. And we have this registration page. Registration page. Registration here. This uses device, and we just added this method here, which is from the gem reCAPTCHA v3. We have the option to add the multiple reCAPTCHA versions, like v2, which is a checkbox, and v3, which acts. It's invisible one, the invisible one. I choose to do this for this demonstration. So we are passing it a sign-up action name that you can identify to verify this CAPTCHA data. I'm just gonna rerun the application here because I added a gem. And yeah, let's see here, refresh the page. And we see that we are already being protected by reCAPTCHA, by Google reCAPTCHA. So let's take a look. But just this isn't enough. I'm gonna add a prepend before action here on the controller, on the registrations controller. So this, for who's not familiar with, it's a device controller which manages our authentication. And I just added this method that's gonna verify the reCAPTCHA. This method is also from the reCAPTCHA gem, the library reCAPTCHA. We're gonna pass the same action, which is sign up. And we have this minimum score. This score goes from 0 to 1, and this, closer to 0 is likely a bot. closer to ones like they are human. So if this fails, we're gonna throw an error. Throw an error not. We are gonna show an error on the response. So we can try to run this now with the captcha enabled. Let's go to our tool again. We're gonna do the same thing that we did before. It's gonna add a valid password here. And okay, so and we're gonna replace this unreachable path for the emails list. Okay, let's start the further. As you can see now, the code, we are getting an error as a response. And if we try to search for this error here, we are gonna find that they have the reCAPTCHA verification failed. So yeah, it's working, the reCAPTCHA is working. We can't create an account using this automation tool, but we can go and create an account ourselves. And we created an account. So yeah, that's basically how a captcha would help your application to prevent this kind of attack. Of course, this is just a demo. It's not a production environment, but you can see the value of adding such kind of defense. So I'm gonna go back again to the slides where we're gonna talk about a few stuff left. Let me just close this here. Close this because they consume my memory. Okay. Okay. I'm gonna share this slide again. Okay, so now we're gonna talk about a few technical considerations when implementing captchas, a few tips we can get from, and a few things we need to ensure to handle. So the first one, when implementing a captcha in your application, you should be concerned about error handling. So when a captcha verification fails, due to an expired token or invalid token, we need to provide a clear feedback for the user, like please verify that you're not a bot and stuff like that. Users need to know what went wrong. We would also add a retry mechanism that can help the user regenerate captcha without refreshing the entire form, especially helpful for users with connectivity issues. Most of this error handling is made by Google reCAPTCHA, but if you are going to try to use our solution, or if you are trying to implement by yourself, we need to consider this error handling. As we saw on the implementation on the registration controller, we can configure a threshold. So it carefully set the score threshold. We should do this based on how suspicious interaction appear. A typical threshold of 0.5 will balance security with user experience. And we can adapt the thresholding by applying stricter thresholds to sensitive actions like login, while keeping it looser for less critical actions like a feedback form. We can give it a lower value. We also have to be cautious of the security concerns. We need to track the token expiration carefully. reCAPTCHA tokens will expire after about 2 minutes. So the front end should check the token age and request a new one if needed to prevent the replay attacks. A replay attack will be when like you pass the captcha once and you use the same token a bunch of times by bots. That's it. So we could avoid this using Unix session relations to ensure that it capture tokens only used once. We also have to ensure that our UI and UX integration is smooth. Like when provisioning a visible captcha, we need to set it logically with the form to minimize the friction. So when captcha verification is in process, we should show a load spinner or send a feedback to ensure that to the user that their submission is being processed. And as I told you, reCAPTCHA also already does this. We didn't provide a visual capture, a visible capture on our demonstration, but it is as simple as switching the methods on the Rails application. And lastly, we need to focus on testing and monitoring because uh, we need to monitor how our capture will behave in our application. We need to test across different browsers and devices to ensure that it's compatible. And we should monitor its effectiveness by tracking success and failure rates and regularly adjust settings as needed, especially for critical forms and to improve the user experience while keeping the security strong. So yeah, that's basically it. That's what I had to bring to you today. And yeah, thanks for watching. Thanks for learning with me. And I'll see you on the next.